One of these balls is fake. And this is not a shitty wallpaper. It's actually a detailed 3D cliff face. So how are we able to manipulate lights like that?
It's because of something we call normal map textures. So what are they?
These are special 2D images that store 3D directional data, and the lighting system uses this data to add fake highlights and shadows and create the illusion of detail.
But how do you store 3D detail in a 2D image?
Digital images store data in 3 channels: red, green, and blue. All the colors that you've ever seen, it's just these 3 colors being mixed at different ratios.
That means every pixel stores 3 values. If we map the 3 directions of 3D onto these image channels, red becomes the x-axis, green becomes the y-axis, and blue becomes the z-axis. And since these channels store data within the 0 to 1 range, we can use that to tell the lighting system how much a surface is facing either of the 3 directions. So for a surface that's fully facing you, you'd expect the values to be 1 on blue and 0 on the other channels, but it's actually 1 on blue and 0.5 on the other channels. That's because the lighting system expects data that's within the -1 to 1 range. And since we can't have negative values in an image, the range just shifts from -1 to 1 to 0 to 1. So values that should be -1 jump to 0, and values that should be 0 jump to 0.5.
So this is how normal map textures look like. So this is the red channel, and it's storing directions that face this way. And then here is the green channel, which stores up and down directions. And then here is the blue channel, and you can see how the values change as per the directions. Here's an actual 3D surface. It has details, and the details are actually popping out. And here is a flat 2D plane with a material that's using a normal map derived from this 3D object. When you look at them closely, you notice that the normal map is approximating the directions very closely. But there's a problem. Since this part is supposed to be popping out, it casts a shadow. But here, it doesn't cast a shadow. And that's because it doesn't really pop out. So that's one of the major limitations for normal maps. We don't use them for large details. We use them for small details where you can't really tell that the details are not popping out.
And that's what's happening with this cliff. The normal map texture for this cliff has those directions baked in, and the lighting system just reads that and manipulates the light accordingly. And that's how we are able to get all this detail.
So since normal maps are used to cheat directions, we can do fancy stuff like creating imposters for trees. This is another example. Those nuts, they don't exist. And the wrinkles, they exist in the normal map texture.
To generate normal maps, we first create a highly detailed surface, then a plane onto which we will project the directions. We call that plane the tangent space.
So that is how we move data from a 3D object onto a 2D image and back into a 3D object. Very cool.